queries so that you can interact with your database. Then you'll be writing Java code that automatically connects to your database to produce the report that you're writing right now, rather than reading directly from a bunch of flat files. So where we're going over the next couple of weeks is up to probably the midterm is databases and in particular SQL and relational database systems, relational database management systems. So this is an example of a flat file. Even though it's not comma separated value, it's still flat data. I've done this exercise before, probably with people in the last semester. But what are some things that are wrong with this data? Lots of repetition. I've got it's an enrollment system, right? So we've got students and we've got courses, and students are enrolled in courses, and the students also have emails. I've got every time a student is enrolled in this course, 156, then I'm repeating that course name and the course number every single time for like Lou Reed, Tom Waits, who else is in there, John Student, et cetera, right? So I've got lots of repetition there. What else is wrong? What's one thing that you had trouble with the games database that you were doing on the first assignment? Right? There were some things that were missing, right? Publisher might not have published any games. What's missing here? We've got Tom Waits at the top there, and he's just in there for that email record, maybe, right? But he's not enrolled in any course for that record. He's enrolled in other courses. He's enrolled in this course, but that first record is there just as a placeholder. So we've got a bunch of blanks on those first two columns. Likewise, down at the bottom, we've got Tom Waits, and instead of just blanks, we've used none and null. So we've got some inconsistency on how we're representing data here, right? So we've got repetition, inconsistency, we call those data anomalies. What else is wrong here? So say again? They're repeated, and they're repeated in different ways, right? On the first record, I've got Waits, comma, Tom, all lowercase. On the third one, I've got Tom, space, Waits. So first name, first name, spelling differences, and capitalization differences. On the fourth one there, I've got J student instead of John student, right? There's no separation of data here. There's inconsistency with data, right? So there's a lot of problems here, right, related with flat files, and a lot of other problems that may not necessarily be completely apparent right away. But we've already seen that there's repetition of data. There is formatting issues, right? There are consistency issues, right? You don't have a consistent way of representing data. There's integrity issues, right? How do I know that this Tom Waits right here is the same as this Tom Waits down here? Well, I can look at their NUID, but that's subject to the same issues, right? I could have data entry over here that I accidentally put in a 5, right? Records are not related to each other in a flat file. You also have organization problems, right? There's no way they're not sorted in any particular order. So if I want to go through and find one record to see if Tom Waits is enrolled in this class, I essentially have to process every single line of the entire file to be sure that he's not in this class, or I get lucky and in the middle somewhere I find that record and, oh yes, he's in that class. There could be 2 records of enrollment, right? He could be enrolled in this class twice, and that's bad because that's inconsistent data as well. That's a data anomaly. Organization problems, that's not sorted, right? It is in one big file, right? And consequently, there is no multi-threaded or multi-user capability. If you open up a file, let's say a Word file. If you open up a file in Word and you start typing, you save, and then you try to delete that file, what's Word going to say? What's your operating system going to say? Anybody ever try this before? Yeah, you got to close it first, right? Why? Because the operating system put a file lock on that thing. It's in use by one program, so other programs like your operating system trying to delete it is not going to be able to access that file, right? It's giving you a warning there. Likewise, with a flat file like this, if thread 1 comes in with user 1 and they want to start reading it to find Tom Waits' record in that enrollment system, then another thread wants to come in and find out information about another student, that thread is going to have to wait until this entire thread is done. There's no multi-threaded capability. You don't have the ability for multiple programs, multiple users to access the data at once, right? Because it's all in one big file that gets locked up the first time somebody tries to use it. There is no security, right? If you give read access or write access to this one file, well, they can read and write or write anything that they want. You can't restrict it to, well, you can go ahead and add records, but you can't delete records. Or you can go ahead and update names, but you can't update enrollments, right? There's no fine-grained security there. It's either shut it off entirely or turn it on entirely. So there's a lot of problems with using flat files. What's the solution? The solution is to use a Relational Database Management System, or RDBMS. Relational Database Management System. There we go. And there are lots of examples out there. I won't get into it, but it goes all the way back to the 70s. This is all started by a guy named Edgar Codd, or E.F. Codd. Edgar, I think that's how you spell it, but Codd in 1970 at IBM. Right. So the relational database model was invented by him. He came up with it, and then that bore out SQL, a way to query that model. The key aspects are that data is stored in tables, right? And you might think of tables as a typical Excel file. That's one table. You can think of that as a table because it's got columns and rows. Data is stored in columns, right? These are fields. And records are stored as rows, right? And so you do have these columns and these rows, but it's not just one single Excel file, right? Excel files, those are spreadsheets. Those are not databases. Instead, what you have is multiple tables. I've got data that represents one thing over here and data that represents another thing over here. And I need a way to relate those two things together. Right? I'm separating them out into other tables. In addition, each row may have a unique identifier called a primary key, or PK for short. Right? And rows, or that is records, in different tables may be related through what are called foreign keys, or FKs for short. Right? In general, the order of a database, the way that they store things is meaningless. It's only meaningful to the database if you've got what are called indexes, and that's something that we'll look at later. The order is meaningless, though. So, what does a database look like? And I'm just going to bring this over here. Right? It looks more like something like this. Here's that exact same data, but represented as a bunch of tables. Right? I didn't name these tables. Let me go ahead and zoom in even more here. But all the same data is there. But now all of the problems are solved. There's no repetition here whatsoever. There's repetition in foreign keys, but that's needed in order to bring a relationship together. And I've also got relationships clearly defined in each one of these tables. There's the top one at the left. That's clearly a student table that stores information about students. It's got a first name, a last name, and an NUID. Let me go ahead and zoom in even more there. Right? And then over here on the right, we've got a course table that has a course ID, a name, and a description of that course. Or that probably should be title. Right? What's the relationship between those two tables? Well, in real life, a student can enroll in several courses if they want to, right? And a course has many students. So what we have is a many-to-many relationship. One student can enroll in multiple courses. One course has multiple students. So to achieve that, what we need is something in between. And this is called a join table. It has records of a student ID and a course ID and a semester in which they were enrolled. So that if you follow this relationship back, look at that first record where I've got a student ID 5. It comes over here. That relates to John Student. John Student is enrolled in course 11132. That course over here is discrete math. And they were enrolled in the fall of 2011. Right? Bringing those two tables together by bringing those values in as two columns. Right? Furthermore, a student might have more than one email. Right? And if a student has more than one email, we need to separate that out into a one-to-many relationship. One student can have 0 emails, 1 email, 2 emails, 50 emails if they want. And the way that we do that is we have a one-to-many relationship here with this table. This is just a visualization. Right? We'll get to the details of how to achieve this later. But in the first record there, we've got the student ID 2, and that corresponds to Lou Reed. Right? That is Lou Reed's email address. But Tom Waits has 2 email addresses because the second 2 records, the second and the third record, are referring to the student with student ID 1. Right? And so by spreading these things out into different tables, we eliminate the repetition of data. We eliminate the potential for data anomalies because if there's only one record that represents Tom Waits, there's only one way to spell his name. Right? And we've separated out the first name and the last name into 2 different columns so we don't have the issue of first name then last name or last name first name. How do we represent that? Right? So it's kind of like what we've done with our objects. When we did our object design, we broke the ideas down into smaller and smaller pieces until we said, okay, this thing is one thing. This thing is an address. Or this thing is a person that has an address. And by splitting those out into other tables, we're doing this from a data point of view as well. Okay? So we're eventually going to get to this. Before we design our own databases, though, let me bring this back over here. Before we design our own databases, we need to learn how to work with a database. So to motivate that, where is it? Here we go. I'm going to give you another database. These are all called ER diagrams, by the way. This one's a little bit prettier because it was actually generated by a program, MySQL Workbench. And it's exactly what you did in your first programming assignment, where we asked you to go through a flat file that represented a bunch of video games that were available on various systems, consoles or whatever, and they had publishers. But now I have created a database to basically model that same thing. We've got a game table, we've got a platform table, and in between we've got an availability table. Note that in this ER diagram, I've got a one-to-many relationship. For example, one publisher can publish many games, but one game only has one publisher. That's the way that I've chosen to model this for now. That's represented in the diagram there by a 1, that kind of hash there that equals, that's just 1. And then the chicken foot on the other one where it's spreading out, that's the many. Right? So there's a one-to-many relationship from the publisher to the game table. And then between the game table and the platform table, there's a many-to-many relationship because one game can be published on multiple platforms, and of course one platform can have multiple games, just like the data that you worked with in the very first assignment. But in the first assignment, you had to go through and you had to actually process the data manually by writing a Java program. Now we're going to learn to do it properly with a normal, that we call this process of splitting it out, normalization. First normal form, second normal form, and third normal form is something that we'll look at later. But this is a well-designed database because everything is spread out so that you've eliminated all the potential for redundancies. You've also eliminated all the potential for data anomalies here, right? And we'll talk about that later. But to get there, we need to learn how to interact with this database, okay? Let's see. Yeah, I don't want that. Here we go. Okay. So we need a way to interact with this database. And the way that we're going to interact with this database is through CRUD, something called CRUD. So you can interact with a RDBMS through CRUD. Right? CRUD is create, retrieve, update, and destroy. Right? Those are the 4 basic operations that you can do with any piece of data. You can create new data. You can retrieve existing data out of your database. You can update data. Existing data is already in the database, but we need to update it because, they changed their name, right? Or we need to destroy data. We need to delete that record from a database. Those are the 4 basic building blocks of interacting with data. And the way that we're going to do that is through SQL. Right? With create, we're going to learn how to use an insert statement. With a retrieve, we're going to learn extensively how to use a select statement. Right? Hopefully this is big enough, is it? Let me increase the size here. There we go. All right. A select statement. With update, the only one that makes sense from the point of view of CRUD is an update statement. And that's the only one that matches. And from a destroy standpoint, that's a delete. Right? So they needed a better acronym. That's why they called it CRUD. If you went the other way, ISUD, ESUD, that doesn't. Maybe you can find SUD, I don't know. But anyway, CRUD is what they is what we call that because it's a cool acronym. Okay. So what I want to do is let's just go ahead and look at let's see what order should we go in here. Well, let me first show you how to start get started with your own database. Let me see. I've downloaded and installed for quite a while now a program called MySQL Workbench. This is what I suggested on the Piazza post that you go and get. It's free. It's put out by Oracle, so yeah. There are other alternatives out there, and you can do this in most IDEs too. I think one of the Michael put in a post on Piazza about how to do this in IntelliJ. You can do it natively in Eclipse if you really want to just stay in Eclipse. I like to keep things separate and connect to my database through something that was built to connect to databases. And so I'm going to use MySQL Workbench for demonstration purposes. MySQL Workbench, again, is free. It's a free download and install. It's cross-platform. And it's also installed on the lab computer, so it'll look familiar when you go to use it. If you want to use something else, PHP MyAdmin is somewhat popular. There are plenty of other IDEs out there. Whatever you want to use, fine. I'm going to go ahead and demonstrate everything with MySQL Workbench here. So it won't look exactly like this when you install it, but you will have a MySQL connections here where you can add a connection. Okay. And I'll walk you through adding a connection here. Like you can say my CSE connection, right? And unfortunately, I can't zoom in on this part. But the host name will be cse.unl.edu. You are not root. You will never be root. Even the sysadmins rarely do things through root. You do it through sudo instead. And so you're going to use your own login, right? My login is Seberg. And then it's going to prompt you for a password. I won't do this because I don't want another connection, but it'll look something like this. Right? It'll prompt you for a password. You can save it if you really want to. When you establish your password and change your password, don't make it the same password as your other accounts, because eventually you're going to be putting this password into your code, sharing it with your partner, handing it in, letting about 15 LAs see your password. So do not use the same password that you've ever used for any other system. Just make a dummy password for this one. Right? I won't tell you my password because I don't want somebody connecting and screwing around with our stuff here while we're working. But I'll go ahead and say OK. Continue anyway. I think I need to update my MySQL Workbench version. Right? And I tried to make it as big as possible. Is that still too small back there? Yes, it is too small. All right, try again here. Preferences, I've got it at 24-point font, I thought. All right, 32, 32, 32, and 32. Okay, I'm going to have to restart it. I was trying to look for a quick key to do this, but yeah. All right, but now it's good? Okay, thank you, good. All right, so forget about that for a second. This is how you get started, right? Initially, you're not going to have any tables in your database, but to get started, you can start to use your database. Right now, if I tried to, like, say, show tables, what tables do I currently have installed on this system? Well, it's going to complain down here, and unfortunately, I can't increase the size here. Show tables, error, no database has been selected. By default, when you come in, unless you configure your IDE or whatever to use a particular database, then you need to start by using your database. Use CBERT. Your database will be the same name as your login. That is the only thing that you have access to on CSE. If you want to go and install your own MySQL instance on your own computer and become a full-fledged DBA, a database administrator, you can do whatever you want. But on CSE, you only have access to one database, and the name of that database is the same name as your login. Right? So I'm going to use CBERT here, and I'll go ahead and annotate this as we go along in SQL, at least the way that I've got it configured here. A hash is going to be a comment. So start by using your own database, right? Your login. Okay. I'll annotate these as we go along. And by the way, how did now I can go ahead and list the tables currently in your database. Right? Well, I'm going to go ahead and show those now. Forget about film. I've got game, platform, publisher, and availability. Well, guess what that corresponds to right here, this database. I've got a game table that stores games, a platform table that stores platforms, an availability join table in between that brings those two things together so that one game is available on this particular system. That's going to be down here in this join table. And then, of course, the publisher's over here. Okay? There I've shown that you can get rid of these things by closing the tab. You might be asking, how did I do this? How did I execute these statements? Well, at least on my Mac here, it's Command Enter to only execute the one that you are currently that the cursor is currently on. Right. So if you highlight something, or if you highlight an entire portion and you hit Command Enter, then it'll execute all of that. If you want to execute the entire thing on Mac, it's going to be Shift Command Enter, and it does everything all at once. Okay. Let me go ahead and get rid of that. If you are on Windows, Control Enter and Shift Control Enter. Test those out. Let us know if that's true. Right? But here I've got I've shown my tables now. Right? I've got availability, game, platform, and publisher. Okay. I want to start by inserting some additional data here. This is what you did at the end of 155E last semester, but you did it through an actual C program, right? Because we had written all the code to connect to this database. You had to add your own favorite game record and make it available on a platform, make it available on a publisher. For now, however, we will go ahead and start with very simply here. Let's add a game. Let's add a platform. Let's add a publisher. Okay? And then we'll worry about bringing those things together. So this is the create, the C of CRUD. Let's go ahead and create a few game records. So to do this, I use an insert statement. Insert into the table that I want to insert into, and the table name here is going to be game, G-A-M-E, game. Values, right? You'll note that here that it's syntax highlighting all of the SQL keywords in blue. You'll also note that I'm writing them lowercase style. Old school way of doing it would be to write them all an uppercase style. I say that that's old school because the reason that people used to do that is they didn't have color monitors. And so they needed a way to offset those things. So in other words, instead of doing something like this, they would have done insert into game values, or values, right? There we go, values. Right? And they would look like this, right? And that's perfectly fine because SQL is actually case insensitive on all of its keywords. Both of those are the same thing. However, we live in the 21st century now, where everything has color. We don't have CRT monitors anymore with green screen where we have to distinguish, is this an SQL command or a table name? And so with syntax highlighting, with colored highlighting, then we don't need to worry about that anymore. So let's stop. Let's stop typing it like that and making our pinkies fall off by holding that shift key down the entire time. Right? I'm going to do it this more modern way of all lowercase, because if you're in any decent IDE or system, you're going to have syntax highlighting like this. Okay? Insert into game values. Well, what do you want to insert here? If I look at the game here, I've got a game ID, and right here, this little colorful, maybe I can zoom in on it. What does that look like? It's a key. That's a primary key. Right? That's a way that you uniquely identify a game. We're going to talk about primary keys and how to create them later on, but for now, you don't have to worry about them. If you create them and design them correctly, the database takes care of that for you. So we're not going to do that. Instead, I want the name of a game, and oh, now I need a publisher ID. Okay, so let's come back over here. I want to insert into the game values name, and well, I don't know any publishers yet, so I'll go ahead and keep it like this. Darn it. Into game. Sorry, these should go over here. Insert into game values. I'll go like this. All right. Give me a game. A what? Halo. Okay. Halo 1, I guess. All right. Halo Reach. Oh, okay. Like that. Okay. All right. So I want to insert a record here for, sorry, I'm looking for something. Okay, there we go. How do I know that this is the way I want to do it? How do I know that I want that as the title rather than, say, the game ID, the name, or the publisher ID? If I try to do this, by the way, it's going to fail. Insert into game, error code, column count doesn't match value count. It doesn't know, there's an ambiguity here. We meant the name of the game, right? Not the game ID or the publisher ID. So to be explicit about that, what you need to do is you need to specify the columns that those values correspond to. So insert into game, the name, the values, Halo Reach, right? And you'll note here, how do I do strings? It's double quotes. You could do single quotes if you really wanted to. And it looks like it's happier about that syntax highlighting there. I like the green better, so I'll go ahead and do it that way. Now let's go ahead and try inserting the game Halo Reach. And it's still going to complain. You know that it's complaining down here because of this little red X here. Insert into game values, error. Cannot update a child row, blah, 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 blah. Let me go ahead and bring this over here. Cannot update a child row, foreign key constraint fails. Let me come back over here to this database design. So do you remember from last semester when you played with this at the end of the semester? To insert a game, what else do you need? A what? A publisher, right? A game cannot exist without a publisher because it's what's called a foreign key, right? Remember foreign keys? That's the way that you relate one table to another table. We've got a game ID, which is, I said, don't worry about that for now. It's taken care of by the database. We've got the name. We know the name, Halo Reach. But what about the publisher ID? We need to say that it was published by a particular publisher. Who was it published by? OG? Bungie. Okay, B-U-N-G-E-E? I-E, okay, thank you. All right, whatever. I don't care about the spelling here. All right, so we need that publisher ID. Publisher ID. We need the publisher ID of Bungie, whoever that is, right? How do I find that out? Well, I do need to look at the other, the R of CRUD before I get into the other R, the C, the U, and the D, right? I need to find out what is that publisher, is Bungie already in this database? So I'm going to go ahead and show you a preview of a select statement. I'm going to select everything out of the publisher table. And we're going to look at all that. Oops, select star. Oh, sorry. Select everything from publisher. There we go. And here are the results. Right? Now, that does have a 32-bit or 32-point font there, so you can see them. I've got LucasArts. This is the publisher ID over here, and this is the name over here. So I've got LucasArts, Sony Entertainment, Sega, Nintendo, ... Do you see Bungie in here? No, so it doesn't have a publisher ID yet. So that's the first thing that I need to do. I need to insert the publisher Bungie first. So let me back up, right? Let me annotate this. Find out what publishers already exist, right? And so I'll actually go ahead and leave it like that. And we found out that Bungie, like that, all right, does not yet exist. So we have to create it first, right? So to create that, we have to insert into publisher. And what do we need for publisher here? I'm going to go back to the database here. Publisher ID, that's a primary key. Again, we'll let the database handle that for us. All we need is a name, right? And at this point, I want to draw your attention to what are the types of these columns. If you look to the right, int, what do you think that stands for? An integer. The other one is a varchar 255. Varchar, variable character. In other words, a string, right? And so the name is a string. The publisher ID is an integer. I don't think I've got any floating point numbers here, but you can have decimals, floats. You can do doubles on some databases. So basically, you have the same primitive types as in any programming languages. You have numbers, integers, you have floating point numbers, and you have strings. They're just called varchars here. The 255 is actually a limit. I'm putting a limit on the size of any publisher name or game title at 255 characters. That's an old school tradition. I think that there might have been a reason for it at some point. 255 is one less than 256, and 256 is addressable by exactly 8 bits. That's probably there's probably a historic reason in there for some reason. If I ever did have a publisher that was more than 255 characters, I wouldn't be able to store that data. I'd have to go back and redesign this database. For the most part, all of those names, though, they're going to be 50, 100 characters at most. Bungie is only going to be B-U-N-G, so 6 letters, right? 255 is probably big enough for most of our purposes. So I'm going to come over here and insert into publisher name, values. And by the way, it's a syntax highlighting name because it is, or at least MySQL Workbench thinks of it as a reserved word, a keyword, but it's actually not. If you do name your tables after keywords, you have to escape them by doing backticks. Oops, those are not backticks. This is a backtick. There we go. There. So if you're gonna name it like, say, order, because you've got orders, then you're gonna have to backtick it, because that is a keyword word value in your in MySQL. Right? Values, and note here that it is plural, even if I only have one. Right? There's no such thing. It might support value, but just be consistent about it. Values, and you said Bungie. There we go. Okay. I will go ahead and execute that one. Right. And down here it says, great, one row affected, it was successful, it's green, it's got a check mark, everything is great. If I go back here and select all the publishers out now, I see that Bungie was added. All right, I can't say that I can go back now and add Halo Reach by simply just saying Bungie, right? Bungie. Right? I can't do that because Bungie is the name of the publisher. What does this require? It requires its ID. Right? That integer, not that string. So how do we get that number that corresponds to Bungie? Well, I can go back and select everything from the publisher here and see, oh, it's 14, right? So okay, I can go back here and say, oh, it's okay. I'll insert it at 14, right? And unfortunately, the primitive types it's highlighting in orange, so it's difficult to see maybe from back there. But I put in 14, right? And that will work. I'll go ahead and insert that value, right? And that was successful. We'll look at what it looks like later here, but you can see really quickly here. Select everything from game, right? And you can see down here Halo Reach. Right? You'll note that some of these might look even familiar, right? The GTA 4, 3, 2, 1, Legend of Zelda, all the way down to Contra and Out of This World. Why? Because this is the exact test case I gave you in your handout on your first homework. Right? So we'll continue to play with my favorite games. Right? You can play with your own favorite games. I have no idea what Halo Reach is. So it's 1, 2, 3, 4, and then reach? Oh, 1, 2, 3, and then reach. Okay. You get up to high enough numbers and you need to start replacing them with words instead to confuse people into buying the game. All right. So I've actually successfully inserted this record. Let me go ahead and change it so that now was Halo 1 published by Bungie as well? Okay. So let's insert that as well. Let's insert Halo, but I'm going to show you another trick here. Instead of hard coding this as 14, you can actually use what are called subqueries. All right. I'm going to. I want to know what the publisher ID of the publisher Bungie is. So let me go ahead and put in a subquery here. Select. I'm going to put it into parentheses here. I'm going to select the publisher ID from publisher where name is equal to Bungie. Right? So here's a nice little shortcut. Instead of hard coding it to 14 every single time, I'm going to make a subquery. And again, we haven't talked about select statements in detail here, but we're going to eventually, by the end of the day. So I'm going to go ahead and insert that game as well. And it's just as happy with that. Rather than hard coding it to 14, I can actually select that out of the database. Let me select everything from the game, and you see here, I've got Halo Reach published by publisher ID 14, Halo published by publisher ID 14. Both of those correspond to Bungie. Okay? All right. That's basic insertion. Okay. Let's go ahead and look at the other. The retrieve will come back to that because that's not the most difficult, but it has the most features. Let's look at the update. The U of CRUD is update, right? So maybe Halo. Maybe I want to go back and change Halo to Halo 1. Was it actually called Halo 1? Just Halo. Okay. All right. You know what? Let's go ahead. Yeah, go ahead. Halo. Oh, Halo colon Combat Falls. Oh, Combat Evolved. Okay, thank you. Sorry. All right. Let's go ahead. And let's rename the Halo game so that it reads as you said. Halo Combat Evolves. Yeah. Okay. All right. So let's do that instead. Right. Well, what if I just did this? Here's the syntax for doing this. Update game set name equal to Halo Combat Evolves. There we go. All right. Now, before I do, by the way, you'll notice I've been ending every single line with what? A semicolon. Look familiar? Yes. C-style syntax. Right? We're ending every single one with. It doesn't have to be that way. You can reconfigure SQL to not have an end line or to use something else, but it's most usual to use a semicolon. So before I do this, which is extremely dangerous, in fact, you know what? Let's just roll the dice and see what happens here. Okay, good. I won my bet. I was banking on the fact that MySQL Workbench is not going to let me do this because it's extremely dangerous. If you look down here, you can't see it here, but you're using safe update mode, and you tried to update a table without a where clause that uses a key column to disable safe mode. What is it trying to tell me there? Update game, update that table, and set the name to Halo Combat Evolves. If you just read that in plain English, which game are you referring to? All of them, right? So if I were not in safe mode here, what would have been a consequence of running this query? Every single game in my database would now have the title Halo Combat Evolves. I only want to update that one record, right? So let me go ahead and again, look at my my game records here. Select everything from game, right? And let's run this. And let's look at Halo, that game right there. Well, how do I uniquely identify it? I look at its primary key, right? Game ID is 23. Right? Oh, by the way, another way that you can do this, because you're using MySQL Workbench, is to simply just double-click it and go blah, right? And now it's been updated. Actually, maybe you might have to hit a button to apply. Yeah, apply. Yep. And it actually generates the SQL right here for you. If you just wanted it to generate the SQL, and you can cut and paste this and use it if you want to. Otherwise, do you actually want to make this update? Yeah, go ahead and apply it. Okay, it worked. Right? And now if I close this and come back and select it out again, you'll see that it is in fact Halo blah, right? But I want to do. I don't want to just do this in my IDE. I want to do this in actual SQL code. So I need to put in a where clause here to limit this update to only one record, the proper record, where game ID is equal to, and what was the game ID? 23. Right? I'll go ahead and execute that update, select it out again, and you see now that Halo has been updated to Halo Combat Evolves. There we go. Okay. And because I was only updating one record, that's considered safe, right? And also note here, how am I specifying that record? It's where the primary key is equal to a particular value. If you were in a programming language, this would be equals equals, right? Java, it would be equals equals. Some programming languages like PHP, where you don't have strict typing, you'd have equals equals equals. But in SQL, you don't have that. You just have the one equal sign because there's no assignment operator. There are things there are temporary variables and cursors that you can get into. We're not going to get into it at that level. If you want to become a full-blown DBA, database administrator, then you'll learn all that stuff and how to basically do everything that you ever wanted to do in a database. We're not going to do that. We're just going to have a gentle introduction to databases so that you don't have to be a DBA. All right. All right. So let me go ahead. Let me go ahead and put this into comment and a warning. The following, without that where clause, would change every record in the game table. Right? So we don't want to do that. I don't want to save yet. There we go. So keep that in mind. And then you can update any table that you want. You can say that we'll do a fuller exercise later on. I'm just getting you introduced to the ideas here. But you can change it so that, it wasn't actually published by Bungie, it was actually published by somebody else. You can update their foreign keys if you want to. You can update any table to any value as long as you're conforming to the rules set down by the database, as long as you're conforming to this structure here. Right? You can also alter tables. We won't get into that, though. Right? So that's the create and the update. What about the destroy? Right? D is for destroy. And we do this through a delete statement. Right? All right, well, I don't actually want those games anymore. I want to delete them. So let's go. Let's just delete Halo, what do we call it? Combat Evolves. Delete from game. Halo Combat Evolves. Right? It's not going to like this. Right? And it's saying that you have an error in your SQL syntax. Check the manual. Check the manual that corresponds to the server version. Blah 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 blah. Right? I like that it tells you to check the manual. It's telling you the RTM. Right? Read the manual. Right? But delete from game. Right? Well, okay. It doesn't know anything about Halo Combat Evolves because that's the name of the game. Right? Let me go ahead and put in another where clause where name is equal to, oops, not that, Halo, I don't want to retype this, Halo Combat Evolves. Right? And if I do this, it's probably going to work, but I don't want to do this just yet. What if I did this? Delete from game. Right? Let me try it. Right? See the little red mark down at the bottom? What's it probably complaining about? I'm trying to delete everything in the entire table, every record in the table. I'm not trying to delete the table. To delete tables, you actually have to drop tables, and I'll show you how to do that later. But I am trying to delete every record in that table. And it's telling me you're in safe mode. You probably don't actually mean that. Right? Well, if you actually did mean that, you could do something like this, where game ID is equal, or where 1 is equal to 1. Right? That's going to be true. Should we roll the dice and try it? Nobody wants to play that? Okay. Don't do it. Do it. All right, I'll do it. Oops. Oh, I didn't. Okay, good. We won that dice roll. It prevented me from doing that as well. I can do something like this, though. Game ID is equal to game ID. Let's try that. Okay, no. How do I actually do this? Now I do want to screw it up. Game ID is greater than 0. That'll probably work. Nope. Oh, wow. Okay. It's really safe mode. Well, let's just verify that all those games are still there. Yeah, they are. Good. All right. So it's real safe mode, right? Safe mode does not allow you to delete every record. Right? And again, I don't want to save. By the way, not every IDE will put you automatically into safe mode. If you're in PHP MyAdmin, I don't know. If you are at the command line, the default is non-safe mode, right? Unsafe mode. So if you're at the command line for your lab next week, understand that everything that you do will be done without checking first, right? You want to delete every record in your tables, it'll let you do that, right? So be careful, all right? But if you put in a where clause where Halo Combat evolves, then even that won't work. Oh, wow, safe mode, there's really strict safe mode here. It's saying, well, no, you can't do that because Halo Combat evolves. That's not its primary key. That's not how you identify a record. If you want to delete a particular record, you need to be particular about that record. So let me go ahead and go up here and look at what that record looks like. Halo Combat evolves. Its game ID was 23. So if we want to delete that, then we need to use game ID is equal to 23. And if I do this, hey, it works. It's now green at the bottom. It says one row was affected. And if I select everything out again, Halo Combat evolves is now gone. Right? There is no undelete. Right? Be aware of that as well. If you want undeletes in databases, you need to set them up to do so, or you need to have database backups. This is why you might have heard that databases are backed up all the time, regularly. The larger the database, the more frequent the backups. Most of our databases in CSE are backed up on 24/7, or no, their user databases are backed up every 4 hours. And some of their lesser databases are probably backed up every 1 hour, or every 24 hours or something like that. And then snapshots are kept and chronicled. In fact, up until a few years ago, they were still using tape backups for the very, very old stuff. If you wanted a database snapshot going back 20 years, they would have had it up on this big tape reel. Of course, getting it out would have been a pain in the butt, but they don't do that anymore. They've got other better solutions now. But now that game is gone. What if I wanted to delete a publisher? So let's try to delete, what was it, Bungie? All right. So I'm going to select everything from the publisher and try to write this query. Select everything from the publisher. The publisher is 14, right? ID is 14. So if I delete from publisher, where publisher ID is equal to, what was it, 14 I said? All right, there we go. If I try to do that, it's going to complain. It's not going to complain because of safe mode or anything, because I did specify a primary key ID here. What it's going to complain about is that I've got a record that refers to it. Let's look at this diagram again. We've got Halo Reach still in that database, right? We've got Halo Reach in that database in the game table. And the publisher, Bungie, published that. There is a parent-child relationship there, right? Depending on how you want to look at it. But the publisher is the parent. Usually this is how you look at it. The publisher is the parent, and the game is the child. If you go and try to delete the parent, what happens to the child? They're orphans now, right? And we don't want orphans. So what we need to do is we need to go in the opposite direction. We need to delete that game that refers to the parent, then we can go ahead and delete the parent. Yeah, it's bad terminology, but that's what's used, right? So we need to delete that other game. What was that game, by the way? Halo reach with an ID of 22. So if we're going to do that, we need to delete 22, right? And then we can delete this, right? And just to show you that I can do both of these at once. Oops. Really? What's wrong? Is it still in there? No, it's still there. Where game ID is equal to 22, go, and go. There we go. Okay, apparently you can't do multiple lines at once, but whatever. And now I was able to delete that publisher here. If I look at all the publishers again, let's say select everything from game and select everything from publisher. I swear that you could do this, and apparently it's not letting me do it, but whatever. Select everything from the game. You see that both of those Halo games are now gone, and you also see that now that publisher Bungie is now gone. Right? So if you've got a parent-child relationship, you need to delete the children, then you can delete the parent. Okay? That's the basic CRUD C C, U, and D. Right? Now what we need to do is start looking at the R, right? The retrieve. Right? That is a select statement. This is probably the most important one because there are hundreds of different ways of doing this. Well, there's only one query, select query, but you can combine it with a bunch of other things. We've already seen a preview of that. Where clauses, for example, so that you can select certain data and you can basically generate reports in your database and modify the results that you get out. Okay? So to start with, what I want to do is, let me see. Let's go ahead and comments here. Let's list all games in the database. Okay? Well, we've already done that. Select star from game. Okay? When I do that, I get every single record in that entire table back. There are only 20 records here or so. Something, if you're working with a large database, something called pagination may come into play. If you've got 1 million records and you select them all, well, 1 million records is a lot, right? It's not going to send you all 1 million. It might start to paginate them. In other words, it sends you the first 20. Then if you ask for more, it sends you the next 20 and the next 20 and the next 20. You see this all sometimes on web pages, right? Showing the first 100 results. Next page, next 100 results, next 100 results. That's called pagination. And it's because there's no way that I can send you 1 million records all at once. You're going to have to get them in a batch here. Right? But that's selecting everything. Let's look at the actual anatomy of this. Select star. Star is a wild card. You are selecting everything with respect to that table. Right? So the star refers to every column in that table. Right? And then you provide the table name. If you want everything from the publisher table, select everything from publisher. Right? If you want everything, and there are all the publishers that we've seen before. What if you want all of the platforms? Select star from platform. Right? There we go. Right? And so there are all the platforms. Let's see. I think that they're all unique, so unfortunately, all right, whatever. What if you don't, let me do that one more time. What do we have in a platform? We have the platform ID and the name. The platform ID is a primary key that's used inside the database, internally. In a report, you're probably not going to care about that. In a report, you care more about the actual names of the platforms or the names of the games, right? If I do this with games, I get a lot of things that I don't necessarily care about. I don't care about the game ID or the publisher ID. I'm only concerned about this column, this name column, right? So if you want to restrict the columns, and in fact it's very good practice to do this, you can restrict the columns you select by using their names instead of the wildcard. Wildcard. Right? So instead of going select star, right, and that's the most common SQL error, by the way, 8, because your pinky wasn't fast enough to get the star there. When you shift 8 to get the star. So instead, let's go ahead and select the just the name, right? Select name from game. And when I do that, I don't get all 3 columns. I only get the name column, right? You can be more. You can list more things. Well, what if you do want the game ID but not the publisher ID? Well, you can put things into a comma delimited list. White space doesn't matter. Right? And now you get the game ID and the name, but not the publisher ID. Right? You can go ahead and manually do everything. Game ID, name, and publisher ID. Well, that takes you back to square one where you're selecting out everything anyway. But this one, in some sense, is a little bit more stylistically preferred because you're not using the star operator. If you're just doing stuff in IDEs, yes, you go ahead and use the star operator all you want. We don't care. But if you are actually writing code that connects to a database, say Java code, JDBC code that connects to a database, and you're selecting everything, even if you only need one column, think about the consequences of that. If you've got, so we've only looked at varchars, strings, integers, maybe floats. There are also things called blobs. Blobs stand for binary large objects. So if you want to store a photo or a video in a database, you can do that as a blob, as a binary large object. Say that I've got a table that has video metadata, like the title of the video. I'm YouTube now. The title of the video, the IDs of all the video, and then, by the way, all the binary data, the megabytes and the gigabytes of data that represent that video. What if I use the star operator now? Select everything, even though I only want to produce a table with all the titles. Right? What am I going to end up forcing it to do? Forcing it to give me all of those megabytes and gigabytes of data over a network just to get the titles, and I'm going to then ignore all the video data. Right? You don't want to do that. You want to be more precise. You want to be more intentional with your queries when you actually start writing them for programs, right? But when we're at the command line here, when we're at an IDE, not that big of a deal. Okay, I'll go ahead and remove that so that you're only selecting those two things. Well, I don't like the name. I think that should have been the title, right? If you look at this, there are names all over the place. There's a game name, there's a platform name, there's a publisher name, right? Publisher name, that makes sense. Platform name, that makes sense. But game, you don't usually refer to the name of a game as name. What do you refer to it as? As the title. Right? I want to change that. So you can also alias your columns. Right? We're not talking about changing the database. If you want to change the database, you have to go back and change the database, change every single aspect of it, rebuild the database, do whatever you need to do to change name to title. I don't want to do that, but I do want to disambiguate it and call it game name or game title. I can do that by aliasing it. Select game ID and name as game title from game. And when I do that, you can't see it very well because it's small, but you've got game ID, and right here, you can see that it's now called the game title. I get the same data out, but the name of the column is now different. It's been aliased. It's now game title. That doesn't change the database. If I go back and select these all again, you'll see that it's still name up here, but if I alias it for that one result that you get back, it's going to be a different name. Right? I can rename this one too as foo, right? There we go. And now you can see that it's foo up here. This is so common that you can actually alias tables, and I believe you don't have to use the as keyword. Right? Yep. But it's best practice to do so. I wish I hadn't shown you that. Right? Always use the as. The only way that you don't want to do this is, or the only time that this would be acceptable to alias, you can also alias a table name, right? So for example, let me go ahead and pull this down, and game as G, right? It doesn't affect the query. It doesn't affect the result set back. But when you start combining queries, because I want the publisher ID, I want the publisher name and the game name. I want those brought together. I want them joined together for one result. Then aliases come into play, because then now to refer to this table, I no longer have to type out game every single time. I can just go G. Right? And again, that's the one time where as is it's forgivable to not put that there. Right? So you can also alias a table name. My game table. Right? You can't use special. I don't know. Can you? No, you definitely can't do that. Can't use special characters. Avoid special characters. You can't use. You should not use spaces either. You note here that how have I been referring to stuff? I've been using lowercasing and singular forms for all of my table names. I've been using camel casing for all of my table values. Right. That's the modern way of doing it. There are other ways of doing it using lower underscore casing for table values and table names. I don't like doing that because, again, if I'm anything like my father, I'm going to get some arthritis eventually. And so I want to not put that off as long as possible by saving my pinky finger from having to go to that shift key every single time. Some people really like lower camel casing, and they must have better pinky fingers than I do. But if you want to save your pinky finger for the rest of your life, then stop doing that. Use a lower camel casing or upper camel casing. Okay? All right. Let's see. All right, in the last few minutes here, let me go ahead and show you a basic join. I want to do this graphically. Or no, we could do some other things here. From author. Oh, the where clause, of course. You can limit your query results using the where clause. So if I just want to select, again, I'll go back to the star here, from game, where game ID is equal to 1, I can select 1, and that's GTA 4, its game ID is 1. Right? If I want to select everything where the game ID is above a certain number, say more than 10, right? You can use numerical comparison operators greater than or equal to 10. Right? You can do that as well. And I only get back Tetris up to out of this world, and I'm not getting those 1 through 9 anymore. Right? You can also do it by string comparisons. So select everything from game where game or name is equal to what was one of those things, Mega Man? Right. There we go. And, no results. I misspelled it or something, right? So you can get no results back. And the number of results that you get back are 0, right? Let me go ahead. What was it? What was it? One word? Oh, that's wrong too. Contra? There we go. And so, yeah, I get contra back. You can, well, what if I just want to know how many are there? How many games are there? You can use a count function to count up the number of records. Right? I don't necessarily want to select all those games with game ID greater than or equal to 10. I just want to know how many games have an ID greater than or equal to 10. I can select a count of everything from game where game ID is greater than or equal to 10. Right? And it'll tell me that there are 11 records there. Probably, what was it, 10 through 20? That makes sense. If I don't, you can do it without a where clause. Right? I'll go ahead and get rid of my where clause, and that'll just tell me how many records are in that entire table. Looks like there are 20 records there. Right? This is where the power of aliasing comes in. If you notice that that result there, it's count star. That's going to be very, very difficult for you to process if you have to refer to it as count star, because what does it actually mean, right? So I'm going to alias that result as number of games. Right? And when I do that, again, you can't see it here because it's really small, but it says number of games, and its value is 20. So that's where aliasing can come in and help you make sense of all of your data. What else and then of course you can do things by string comparisons are just using the equals sign. So for example, select everything from game where, I already did this up here. So let me get rid of this. Loose string comparisons. You can find records beginning with a character or string using the string wildcard. Well, we already have a wildcard in SQL. It's a star, but that's a keyword wildcard. What about a string wildcard? I want to find everything that begins with G. Right? Well, the wildcard with respect to strings is the %. So I want to select everything from game where name is like the following, G and then a % here. What's that going to return? Oops, where game, equals this. There we go. No, what? Oh, that's right. Where it's, well, here, we can do it this way too. That's strict equality, so that's not going to work. If I want loose string comparisons, I need to use the like keyword. Let me go ahead and select this and show you what it does. All 4 of those GTA records start with a capital G, right? And what about a lowercase g? And I'm 50-50 on this as well because I don't know how they've set up the database to be case insensitive or not by default. Okay, good. Thankfully, they fixed that. At least 3 years ago, their default MariaDB implementation was to have a case-insensitive character set by default for all varchars. They fixed it. So it is now case-sensitive. We're good to go. Right? Select star from game where it starts with a big G, right? And you get this. You could select everything where it starts with GTA space and get the same thing, except for that 4th record that was just GTA 1. What was it? Oh, no space. Thank you. GTA, I'll still get this, but there's no space after it. So when I put that space in there, it limits it to those first 3. When I do, say, 2, right, then I'm only going to get that 1 record because the other one is 3 and the other one is 4, which is IV. Right? You can, let me go ahead and move it back to this, but you can also use multiple ones. So you can use multiple wildcards as follows. Right? So select everything where it starts with a G. You know what? Let me go ahead and show you this instead. Or it starts with a C for contra, because I know it's there. Oh, come on. Or, sorry, I need to put the full clause in there. Name like C. There we go. There. And now I'm getting back multiple records. What was that, by the way? I'm using the keyword or. It's not a 2 vertical lines like it would be in a C-style programming language. This is more like Python, right? What if I want to do and? Well, that's not going to make much sense because can a string begin with both a capital G and a lowercase g? No. So I'll go ahead and go with and it ends with a 2, right? So it matches anything as long as it ends with a 2. And I'll get GTA 2. Right? You can use multiple wildcards within the same string. So select star from game where name like. I'll say that it can begin with anything as long as it's got a lowercase o in it somewhere. Be consistent about this. There we go. That's just a lowercase o. That's hard to read. A. There we go. As long as it has a lowercase a in it somewhere, I want that result. Well, everything has a lowercase a in it. I should have chosen, I don't know, what? Oh, that's a good point. GTA records are not there, but a lot of the other records are. Less common ones, is there anything with a Z in it? Nope, nothing with a Z. Is there anything with a X? Capital X? Why? What did you see? X-wing. Okay, there we go. Even though it begins with it, I said wildcard, then capital X, and a wildcard anywhere inside. Right? So it'll match that. The wildcard matches anything. Of course, if you just have a single wildcard, then what are you saying? Well, just give me every single record, right? And that's kind of useless. You might have not have had a where clause at all. Let me go ahead and restore that though. Oops. Okay. Any questions so far? No? All right. Then distinct. We'll look at some of these things later on. But what I want to do is I want to show you a motivating example here for next time, because this is where we'll start off next time. let's see. I don't want the group by clause. Yeah, okay. Well, let's do that. We'll start with the group by clause next time. I want to do some complex data crunching. So I've got a table here that represents not games anymore, but books. I've got the title, the author, and the number of copies. Say I've got a library. I've got 10 copies of Naked and the Dead by Norman Mailer. I've got 7 copies of Ender's Game by Orson Scott Card. I've only got 1 copy of Long Dark Tea Time of the Soul by Douglas Adams. I want to start asking questions like, in my collection, in my library collection, how many total books do I have by Douglas Adams? In other words, I want that 4 plus that 2 plus that 1. I want that 7. I want to know that 7. Or I want to know how many books do I have total, or how many other things, other more complex queries like that. That gets into a group by clause. What I need to do is project the data. What does projection mean? Take a cube, right? And if I project it down onto a 2D surface, what do I get? A square. So a cube is 3-dimensional, a square is 2-dimensional. What if I take that 2-dimensional square and I project it down onto a 1-dimensional surface? Just a line. What do I get? A line segment. Okay? That's going down, that's projecting up. What if I go up? What if I take a square and I project it up? I lift this square up, now I've got a cube. What if I take a cube and I project it up even further? What's beyond the 3rd dimension? The 4th dimension. What do you get? You get a tesseract, right? And now there are at least 3 or 4 movies in the last 5-10 years that have made the tesseract very famous. One of them being the Avengers, right? The tesseract that they one of the diamonds that he uses. What is it called? Infinity Stones. Thank you. All right. And then the other movie is Interstellar. Where does he go to travel through time? He goes to the tesseract, which is just nothing more than a cube projected up to the 3rd dimension. Right? It's just a cube within a cube with all of the endpoint vertices facing each other. If you go to the math department, they've got a tesseract there. Not a real one, but a 3-dimensional representation of a tesseract. Yeah, if they have a real one, you won't be able to see it. That's the basic idea. I need to take this data, which is in some sense 3-dimensional data because it's got 3 columns, and I need to project it down to a 2-dimensional space. I need to project it so that all the Douglas Adams records are collapsed in on each other, and I take the sum of all those numbers in that 3rd dimension, so that I get something that looks like this. Right? I'm projecting 3 dimensions down onto 2 dimensions, just like I did with that square or that cube onto a square. Don't think of it in terms of 2 dimensions, 3 dimensions, 4 dimensions. Think of it in terms of n dimensions, and you can see how complicated it'll get. Don't worry about it, because we've got an easy way for a database to do that for us. Right? Just like we can't actually see a real tesseract unless we become 4-dimensional beings ourselves. All right. We'll continue there on Tuesday.